Welcome back to the episode here on the Unknown Code YouTube channel. As always, I'm Ethan, and today we are going to be going over find numbers with even number of digits here on LeetCode. This is obviously number 1295, as you guys can see on the screen. And the goal of this problem is to take an array of integers, as we can see here, and loop through them and figure out how many numbers are even inside of that list. Now this seems like it's pretty trivial, but there are actually multiple ways to do this. The first way is kind of going to be sort of a brute force way, and then the second way is going to be a bit of a mathematical way as well. Let's actually go ahead and do a walkthrough of a couple of the examples, starting out with this first example right here, and then we'll go ahead and do this example. So let's go ahead and start working through these. So inside of example number 1, we are of course going to have our nums, and nums is going to be equal to 12. It's going to be equal to 3, 4, 5. It's going to have 2. It's going to have 6, and it's going to have 7, 8, 9, 7. So now obviously what we want to go through is we want to take a look at all of these numbers. So this number right here has 2. This is even. This number has 3. This number has 1. This number has 1, and this number has 4. So now, as we see, we have a number with 2 here. So 1, 2 would want to go ahead and return 2 even digits here. And in example number 2, we're going to have, once again, our nums. And this time, inside of the nums array, we're going to have 5, 5, 5. We're going to have 9, 0, 1. We're going to have 4, 8, 2. And we're going to have 1, 7, 7, 1. So once again, we want to go through, loop through these, and be like, okay, this one has 3, this one has 3, this one has 3, this one has 4. So now we only have one that has an even amount of digits, so we're going to go ahead and return 1. This is going to be what our basic problem is. Let's go ahead and take a look at our constraints to see if we can get any more context clues from there. In our case, the length of being 1 to 500 it's not really that big of a deal to us. We could obviously brute force this if we wanted to. Not that we're going to need to, but it's only ever going to be up to 500 characters, so you could get a pretty slow runtime and be okay with this. The bigger one that I want to take a look at here is the 1 is less than or equal to nums I is less than or equal to 10 to the 5. So this is basically going to tell us how large our numbers can be inside of this array. And this is helpful for us because now we know that we can only have numbers between 1 to 100,000. So this means that we can't have any numbers smaller than 1, and we also know what the hard limit is on top. And we can actually go ahead and use this to figure out some pseudocode and figure out how we can solve this. So let's go ahead and hop down below and figure out some pseudocode. So the easy way to figure out this problem is to use your knowledge of math and figuring out whenever something is divisible by something, how many digits is it going to have. Typically for us, we use decimal way of counting, meaning that we go by values of 10. So we can actually figure out how big a number is or how many digits a number has by dividing it over and over and over again by 10. So the easy way, or the quote unquote not as pretty way to do this, is to go ahead and just say for each item inside of nums, then for each value inside of num, we can go ahead and see if it's divisible by the next power of 10. So for example, value divisible by 10 to the 0, question mark. This is 1 digit. Value divisible by 10 to the 1, question mark. This is 2 digits. Value divisible by 10 to the 2, question mark. This is 3 digits. Value divisible by 10 to the 3, question mark. This is 4 digits. Value divisible by 10 to the 4 will be 5 digits. And then finally, value divisible by 10 to the 5 will be 6 digits. So for each element, we'll determine whether or not they are divisible, and then count up if they are actually divisible by some value. So for example, if they're divisible by 10 by 1, we want to count. If they're divisible by 10 to the 3, we want to count. If they're divisible by 10 to the 5, we want to count. Then we want to go ahead and return that value, or the counted value. So at the end of everything, we want to go ahead and return that count. This is primarily straightforward. Let's go ahead and take a look at how this would break down for our first example. In our first example, we have nums. And nums is going to be equal to an array with 12, 345, 2, 6, and 7, 8, 9, 6. For us, whenever I is equal to 0, value is going to be equal to 12. 12 divided by 1 is greater than 0. Okay. So now 12 divided by 10 is greater than 0. Okay. Now, and I should probably say greater than 1, but it is what it is. And then finally, 12 divided by 100 is no longer greater than 0. So now this means that there's 2 digits. The next, we'd have I equal to 1. Here, val would obviously equal to 3, 4, 5. And then here, we'd have 3, 4, 5 divided by 1 is obviously large enough. And then we have 3, 4, 5 divided by 10 is obviously large enough. 3, 4, 5 divided by 100 is large enough. And then 3, 4, 5 divided by 1000 is going to be smaller. So then that means we have 3 digits here. And on the top here, we want to count plus plus. For I equal to 2, we're going to have val equal to 2. And now this is going to be 2 divided by 1 is obviously large enough, but 2 divided by 10 is no longer large enough. So now digits is equal to 1. 1 digit. For I equal to 3, we're going to have val equal to 6. And then obviously we'll have 6 divided by 1 is fine, but 6 divided by 10 is no longer fine. So now that means that there's 1 digit. And finally, for I equal to 4, we'll have val equal to 7, 8, 9, 6. And then here, what we'll have is we'll have 7, 8, 9, 6 divided by 1. 7, 8, 9, 6 divided by 10. 7, 8, 9, 6 divided by 100. 7, 8, 9, 6 divided by 1000. And we can also say 7, 8, 9, 6 divided by 10,000. Now we're going to reach our hard limit. So now digits will be equal to 4. Count plus plus. And now we'll go ahead and be done at the end of this and go ahead and return 2 because we have 2 count right here. So then we'll go ahead and return count. And I'll make my example space bigger later on. I'm still in the testing phase of this. With our pseudocode and example walkthrough, let's go ahead and hop onto LeetCode and solve this problem. So inside of our find numbers, we're going to need to do a couple of things. First off, we'll go ahead and set a count to 0. That way we can keep count. And then we want to go ahead and say for int I is equal to 0. I is less than nums.length and I plus plus. So we want to loop through all of our numbers inside of nums. And then we're going to have a Boolean called even, and we're going to set this to false. So now, like we said before, we're going to use the powers of 10. So first we're going to say if nums of I divided by 10 is greater than or equal to 1, because this is integer division, we're going to go ahead and say even is equal to true. And then we're going to go ahead and say if nums I divided by 100 is greater than or equal to 1. We're going to go ahead and say even is equal to false. We're going to say if nums I divided by 1000 is greater than or equal to 1, then this is going to be even equal to true once again. We're going to have if nums I divided by 10,000. I believe that's 10,000. We'll add that there. It's greater than or equal to 1. Then this is going to be even equal to false. And finally, if the nums I divided by 100,000, so this is the largest number that we could possibly occur, is greater than or equal to 1, then even is equal to true. And then at the end of this, we're going to go ahead and say, hey, if this was even, so let's say if even, it's not JavaScript, we have to say equal to true. If even is equal to true, we're going to say count plus plus. And then at the end of this, we're going to go ahead and say return count. So now we should be able to go ahead and return count. Let me double check that we're inside everything. Let's go ahead and submit this. There we go. This beats 98%. Obviously, this isn't perfect, but still pretty darn good. It beats 98%. So this one, it says there's a 0% or there's a 0 ms runtime. However, it's really hard to get there, and I think it's just random because I've literally copy and pasted the code from the 0 ms runtime, and it doesn't actually do anything. So just kind of keep that in mind. But that is how we can go ahead and do this. Let's go ahead and hop back in, and I want to show you all a little bit even nicer code that is a lot smaller and compact, and it uses some mathematical equations to actually deal with this. So like we mentioned before, the solution above does actually work, and it is basically faster than a whole bunch of other ones. However, we can go ahead and remove most of the if statements inside there and use a single mathematical equation rather than trying to divide each one by all the powers of 10. Luckily for us, Java provides a math library with a bunch of different common calculations, including the math log 10 method, which can actually determine the number of digits inside of a number. The log 10 method will go ahead and take a decimal, which will need to be rounded to the nearest integer. The only caveat we'll have to work around is that whenever you call the method log 10 with the value 1, it's going to return 0. So we'll have to go ahead and round that down and add 1 to each to deal with that. So let's go ahead and figure out a new pseudocode. Once again, we'll have to go ahead and loop through all the values. So we'll go ahead and say for each value inside of nums. And then what we want to go ahead and do is we want to say, hey, the number of digits is equal to log base 10 of value. Then we'll go ahead and take the value of log 10, and we need to go ahead and round it to the nearest int, rounded to int, like that. And then we can go ahead and say digits mod 2 is equal to 0. Then we can count plus plus, otherwise continue. And then at the end of the loop, we want to go ahead and return that count. Right? So this is going to be a lot cleaner and a lot simpler code. Let's go ahead and take a look at walking through this example and seeing that it works. Once again, using the example of nums equal to 12 and 3, 4, 5, and 2, and 6, and 7, 8, 9, 6. We can go ahead and say iteration 1 or iteration 0, the value is going to equal to 12, and then log 10 of 12 is going to equal to 1.079, rounded down to 1, plus 1 is equal to 2, then I is equal to 1, value is going to equal to 3, 4, 5, log 10 of 3, 4, 5 is going to equal to 2.53. Round that to 2 plus 1 is equal to 3. Iteration I equals 2. The value is going to equal to 2. Log 10, 2 is going to equal to 0.3. Round this down to the nearest integer, which would be 0 plus 1 is 1. I equal to 3. The value would equal to 6. Log 10 of 6 would be equal to 0.77. Round that down to 0 plus 1 is equal to 1. And then finally, we have I equals 4. The value would equal to 789. 6. Log 10 of this, 7896, would equal to 3.89. And then we go ahead and round that down to 3 plus 1 is equal to 4. Of course, now next one would be I equals 5. This is end of the iteration, end of loop, because we went out of bounds. Then we go ahead and return the count. And we would have counted at steps right here. So we would have said count plus plus at this point. Then we would have said count plus plus at that point, returning 2. So that should show that it works. And if you guys want to double check my math, you could definitely go on and check out a logarithmic calculator. Let's go ahead and hop back into LeetCode, and I'll show you how simple this is. Back inside of LeetCode with a nice clean slate, we're going to need an int count to keep track of how many digits we have found that are even. Then we need a for loop for int I equal to 0, I is less than nums.length, and I plus plus. And inside here, we're going to say int digits is equal to, and we need to make this an integer. And then we are going to say math.log 10 of nums I. And then we need to add 1 like we mentioned. So what this is going to do is this is going to round it to the nearest integer for us because we're casting it. Obviously, this is returning a floating point. And then since integers are not floating points, it'll basically cut off anything and then return the integer. And then we're going to add 1 like we mentioned to counteract the log of 0, 1 being 0. And then we're going to go ahead and say if digits mod 2 modulus 2 equal to 0. So if it is an even number, we're going to say count plus plus, and then we're going to go ahead and return the count at the bottom and submit this. As we see, it still says 1 millisecond and beats 98.8. You can't really get any much faster, but you also see that now we beat 82% of our space complexity as well. So that is how we can go ahead and solve this problem in a couple different ways. Again, the code will be down below inside of a GitHub if you do want to take a look, as well as a write-up with this problem. If you enjoyed, please make sure to like, comment, and subscribe. As always, my name is Ethan on LeetCoder. I appreciate you all for watching. Peace out, everybody, and have a great day.